Let's discuss some things about forces. First of all, we will begin with the like parallel forces and the unlike parallel forces. So, what is the like parallel forces? Basically, two or more forces which are acting in the same direction parallel to each other. The effect of these forces is that the forces will eventually add up, resulting in a greater net force in that particular direction. For example, suppose there's a heavy box and two people are pushing it in the same direction. So, suppose the person A is applying F1 and the person B is applying F2 on the box, and the resultant force is equal to F1 plus F2 because, like, both the persons are pushing the box in the same direction, so the individual forces of the two persons will add up into F net, which is basically the total force exerted on the box by the two individuals. So what are unlike parallel forces? Basically, these are two or more forces which act in opposite direction and are parallel to each other. These forces obviously will cancel out each other, resulting in a net force of zero or a reduced force in one direction. For example, take two persons, A and B, which are pushing a heavy box in opposite direction. A is pushing the box towards left and B is pushing the box towards right. A is applying F1 and B is applying F2, but the direction is opposite of the two forces. The direction of the two forces is opposite, which will result in the cancellation of the two forces, resulting in a net force of zero. Okay, so basically, the next topic is addition of forces. Addition of forces. The addition of forces, also known as the principle of superposition, states that the net force acting on an object is the vector sum of all the individual forces acting on it. And mathematically, we can represent this definition as F net is equal to F1 plus F2 plus F3 and so on till Fn, where F net is the net force acting on the object. F net is the total force acting on the object, or the sum of all the forces, individual forces which are acting on the object, while F1, F2, F3, Fn are the individual forces which are acting on the object. Let's discuss a bit of what is like head to tail rule. Let's discuss something about it. So, head to tail rule. It is also known as the triangle rule or parallelogram rule. It is basically a graphical method for adding vectors. It states that to add two vectors, place the tail of the second vector at the head of the first vector, and the resulting vector is the sum of the two original vectors. Let's see the step-by-step procedure so that you can understand it in a better way. So first of all, we draw the first vector A on a coordinate plane. So first of all, we will draw a first vector A on a coordinate plane like this. Alright, place the tail of the second vector B at the head of vector A. So I'm placing the tail of the second vector, which is B, on the head of vector A, like this. You understand? So draw the resulting vector C from the tail of vector A to the head of vector B. So this is basically our resulting vector, which is from the tail of vector A to the head of vector B, like this. Sorry, this is our resultant vector. This is vector A, this is vector B, and this is our resultant vector. Vector C is the sum of vectors A and B. Alright, so this was the step-by-step procedure for your better understanding that what is head to tail rule, so that you can apply it to everyday life problems such as the one given below. Let's see what it has to do with our logic. Here's a simple example. Let's read it out. So what is the problem? You have to focus that what is being asked in the question, so that it will be very simple for you to answer it. a boat is moving with a velocity of 3 meters per second east, which is the vector A. A wind is blowing at 2 meters per second north, which is the vector B. So what is the resultant velocity of the boat? So what they asked is, the velocity of the boat is towards east and 3 meters per second. And a wind is blowing towards north at 2 meters per second, which is the vector B. So they want us to tell what is the resultant velocity of the boat. First of all, we will draw vector A, which is 3 meters per second east. This is vector A, which is 3 meters per second to the east. A wind is blowing at 2 meters per second north, which is the vector B. So we have to draw vector B, which is basically the wind, which is at 2 meters per second north. And we have to place the tail of vector B at the head of vector A. Okay, so let's see. This is our vector B. Now we have to draw a resultant vector from the tail of the vector A to the head of the vector B. We have to draw a resultant vector from the tail of the vector A to the head of vector B. Like this. This is the vector A. Alright, this is the vector B. And this is our resultant vector. Okay, so to find the value of resultant vector C, we are going to use the Pythagorean theorem. We will take the magnitude square root 3 square plus 2 square, which will become square root 9 plus 4 and square root 13. Solving it by calculator, you will get 3.6 meters per second. With the help of a D, you can find its angle, which is approximately 33 degrees north of east. And the value and the answer to this question, the answer of vector C is basically 3.6 meters per second at an angle of 33 degrees north of east. So here's how you will solve simple life problems regarding head to tail rule. Thank you.